How are F1 carbon fiber monocoques layered for maximum strength? Imagine a shell so tough it can protect a driver during a crash yet be light enough to help the car go faster. That's what a carbon fiber monocoque in Formula One racing does. Now, how do engineers make it so strong? Let's break it down. First, they start with sheets of carbon fiber fabric. These fabrics are made of very thin fibers, about 5 times thinner than human hair. They weave these fibers into different patterns to handle different types of forces. The layers are laid into a high-precision mold that shapes the monocoque. Usually, they use between 2 and 5 layers for the outer skin, with fibers oriented in specific directions. This orientation is key because it helps the shell resist forces from different angles, like impacts or twisting. Next, they add a lightweight core material between the outer shell and an inner layer of carbon fiber. The most common core is an aluminum honeycomb structure. This honeycomb acts like a stiff sandwich, making the whole monocoque much more rigid without adding much weight. It also helps absorb energy during crashes, keeping the driver safe. Sometimes they use Nomex honeycomb, which is fire-resistant, for extra safety. Then, they lay down another set of carbon fiber layers on the inside, again 2 to 5 layers with fibers oriented to support the outside layers. This creates a sandwich structure that is both light and incredibly strong. The layers are carefully aligned to handle different loads and impacts. Once all the layers are in place, the entire assembly is vacuum bagged. This process removes air pockets and ensures all layers stick tightly together. Afterward, it is cured in an autoclave, a special oven that applies high heat and pressure. The curing process, at about 180 degrees Celsius and up to 7 atmospheres of pressure, solidifies the resin that binds the fibers. This makes the monocoque a single, rigid piece. The thickness of the monocoque varies depending on the area. Some parts might be just 1 millimeter thick, while others, especially where impacts are more likely, can be up to 20 millimeters thick. Engineers use computer-aided design and finite element analysis to decide exactly how many layers and what fiber orientations are needed for each section. In the end, this layered approach creates a shell that weighs as little as 35 kilograms but can withstand severe crashes. It's a perfect balance of strength, safety, and weight. This is how F1 engineers craft monocoques that protect drivers and help make the cars faster and safer on the track.